Hello everyone. I'm going to show you an incredible trick, transforming something seemingly useless into a powerful, versatile tool. I suspect it's just dead batteries, so I'm going to remove the old ones to see what we're working with. A loose battery could also be the reason the alarm clock isn't working. I reinserted the battery, but the alarm clock still didn't respond. I have a new AA battery. I'll try putting it in the alarm clock. The alarm clock starts working immediately. The main reason is that the battery is dead. To confirm my suspicions, I'm using a multimeter. First, I'll test the good battery to show you a reference voltage. See how it registers around 1.5 volts. I quickly marked it to avoid confusion. I used a marker to write a V for the battery with good voltage. Now let's test the old battery. As expected, it shows absolutely no voltage, confirming it's completely dead. With this depleted battery, I mark it with an X. So we have a good battery and a dead one. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. I've prepared 2 small jars. I'm filling both of them with regular water. These will be crucial for our revitalization process. I'm making sure they're filled to a similar level for consistent results. In the first jar, I'm adding a generous amount of red Himalayan salt. I'm stirring it thoroughly to ensure it dissolves completely. This will create our positively charged electrolyte. The dissolved salt will increase the water's conductivity. For the second jar, I'm using regular white table salt. Again, I'm adding a good amount and stirring until it's fully dissolved. This will serve as our negatively charged electrolyte. The difference in salt type will help create the electrochemical potential we need. I'm labeling the jar with the red salt solution as plus for positive, and the jar with the clear salt solution as dash for negative. This will help us correctly connect our circuit later. Next, I'm taking 2 insulated wires, one red and one white. I'm stripping a small section of insulation from each end of both wires to expose the copper. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. Then, I'm twisting the copper strands tightly for a good connection. I'll wrap the exposed wire from the red wire with a small piece of red electrical tape to distinguish it. I'm attaching the taped end of the red wire to the positive terminal of the dead battery. This tape provides insulation and helps secure the connection. It's essential for a stable circuit. Now, for the other wire, the white one, I'm wrapping its exposed end with black electrical tape. This will connect to the negative terminal of the battery. I'm ensuring both connections are secure to prevent any disconnections during the charging process. This entire setup is forming a simple charging circuit for the dead battery. I'm taking 2 metal nuts and twisting them onto the loose ends of the red and white wires. These nuts will act as our electrodes, providing a larger surface area for the electrochemical reaction in the salt solutions. A secure connection to the nuts is important for efficient electron flow. Now, I'm placing the nut from the red wire into the plus red salt solution, and the nut from the white wire into the dash clear salt solution. The battery is now connected across these 2 salt solutions. To power the setup, I'm using a standard phone charger. I'm connecting the charger to the positive and negative ends of our battery, and then plugging it into a power strip. Watch closely. You can already see small bubbles forming in both jars, indicating that current is flowing and electrolysis is beginning. Take a closer look at the jars. We're getting some strong bubbling in both jar. You can also observe a change in color in the positive jar, with the red solution becoming lighter as the reaction progresses. This is the magic of electrolysis, where the salt water acts as a medium to transfer ions and recharge our battery. After a while, I'm disconnecting the charger from the power source and then from our battery setup. The electrolysis process is complete for now. I'm also removing the metal nuts from the wires. I'm carefully unwrapping the wires from the battery. Remember that dead battery? Let's check its voltage with the multimeter once more. Look at this. The multimeter now shows 1.53 volts. Our previously dead battery has been successfully recharged using just salt water and a phone charger. This really shows what's possible with a little DIY ingenuity. Let's put this new battery back into our alarm clock. I'm securely placing it in its compartment. And there you have it. The clock hands are moving. The alarm function works perfectly. Our simple, discarded alarm clock is back in action, all thanks to this unexpected revitalization. If you enjoyed this project and found it inspiring, please give this video a big thumbs up, share it with your friends. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next one.